Hey there, Mrs. Bjornson's back for more math. This is our last section of this chapter, and this is factoring what are called differences of squares. Now, these are binomials, and what we are going to learn, other than taking out a GCF, when you have a binomial, this is all we've got. This is our only method. So, the good news is that these are quite simple. I'm going to attempt to explain the why. However, sometimes the why is harder than the actual process I find in math. But I'm going to do my best. I think I'm going to skip using algebra tiles, though, since we haven't really been using them in this course. Sometimes I use them and sometimes I don't. I'm going to instead opt to use a tic-tac-toe here. Now notice we have an x squared term. Always put the x squared term in the middle. Since this doesn't have, this is my last term. This is my constant. We're going to put it here. Now this is interesting here. There is no middle term. The middle term is missing. But how can that be? Let's start reverse tic-tac-toeing it here. This has to be an x and an x. Yeah? It has to be an x and an x. And we have some options here for the -4. I could put a -4 here and a -1 here, but that's not going to work. It's not going to work. Well, let's go with the perfect square first. Let's put a +2 and a -2 and see what happens when we fill in the oi in FOIL. So x times -2 is -2x. X times +2 is +2x. And lo and behold, what do those sum to? Those sum to 0. We have 0 as the middle term. The oi in FOIL goes to 0. Okay, do you see that cool move? I just turned that 0 into an oi. That's the key. That's the key for these differences of squares, is that we need to have the oi sum to 0. And the only way for that to happen is to have one of them be negative and one of them be positive. Otherwise, you're not going to sum to 0. Here, let's do it again on this middle one. 4x squared, -1. These are perfect squares. This is a perfect square. So what we're going to do is we are going to pull out, go 2x this time, and 2x. 2x times 2x is 4x squared. Now what multiplies to -1? Not a heck of a lot. We have to have a -1 and a +1 to multiply to that -1. Now let's fill in the oi in FOIL, and holy smokes, if it doesn't equal to 0, we're in trouble. So let's hope it equals to 0. So +1 times 2 is 2x. 2x times -1 is -2x, and we are good because that sums to 0. Okay, so we're all good. We're all good. We're all good. Now, watch what happens, though, when we come over to this. This one's a little bit funky. It looks like it's the same. X squared +1. Notice over here I had a -4 and a -1. Everything's happy, but something is going to be not so happy because of this plus. Watch what happens. We have an x and an x. Now there's only two things that can multiply to +1. It has to be +1 and +1, or, hopefully you're thinking this, -1 and -1. Those are the only two options to multiply to +1. So let's see what happens to the oi. We've got a -x and a -x. Oi, oi, oi. Those do not sum to 0. Those sum to -2x. So we're in trouble there. Okay, let's see what happens. Oops. When I change these to plus and plus. Then I have a +1x and a +1x. What do those sum to? Not to 0. What do they sum to? They sum to +2x. There's no way that the oi is going to sum to 0, but it has to. Look, there's only two terms. There is no oi. There's no oi there. So we can't have an oi if we don't start with an oi. Does that make sense? We can't end with an oi if we don't start with an oi. So what we have here is a problem. The problem is that we cannot factor. When it is a sum of squares, this is not factorable. Only when it's a difference of squares can we factor it. Sums of squares are no good. So what observations can you conclude? I want 2 observations here. Let's see what you got. Pause the video and see if you can think of what I'm thinking. Okay, good luck. Okay, it's very possible that you observed something else, but because this is a video, this is the downside of videos. So I'm not going to say that what you have is wrong because I don't know what you put down, but this is just what I put down. And if you want to check with me later, please, I would love to talk to you during class time. So what I noticed is that we can only factor if we have differences of squares, not sums of squares. That's a big one. And take a look at the answers here. If I grab a different color, these are the factors. Across the top, and then these didn't even become factors. So there is a pattern going on with the actual factors. I didn't write that down here. And the reason why I didn't write it down is I have it in a scroll. And whenever I have a scroll, I like to have somebody reading the scroll, like in ancient times. Hear ye, hear ye. Usually they have like those really long wigs on, the squire and stuff. Okay, hear ye, hear ye. This is really important, so I have a scroll around it. That the rule for factoring differences of squares is that it's going to be a minus b, a plus b. Now this is the funky part. I really find that students remember it if they say it like this, and don't say it like this, a minus b, a plus b. That's boring. If you say it like this, you will remember it better. So listen up. A squared minus b squared equals a minus b, a plus b. Make your voice go up higher on the second one, because what that will do to your brain is it will remind you that the two have different signs, that there's a change. One's minus, one's plus. So it doesn't matter if you go a plus b, a minus b, but just make your voice go up higher every time you do it. Okay. Now, don't forget the golden rule of factoring. Always do what? Always look for blank, blank, blank. What goes in the blank? Hopefully you are saying GCFs first. Your life will be much easier if you take out any GCFs before you start any other factoring process. All right, so we're going to play a game. It's called Spot the Differences of Squares. You have to first of all be able to identify whether or not you have a difference of squares. So I've got 6 questions here. What I would like to do, I'm going to pause the video and I want you to put circles around just the numbers that are differences of squares. You need to look for perfect squares and subtractions. Okay? And if it is not a difference of squares, can you circle the little bit of the question that is making it not a difference of squares? Okay? Good luck. Okay. 4 out of the 6 of them are differences of squares. This one gets people, but I'll show you why in a sec. So let's go ahead and factor the ones that we can right away. So say it with me. When we factor this guy, it's going to be we take the square root of the first minus the square root of the second, and then the square root of the first plus the square root of the second. Remember, we're going to use this to get from here to here, you have to root the a squared. To get from here to here, you have to root the b squared. Okay, so we're rooting. Root, 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 root. Like cheerleaders, math cheerleaders. Okay, so we're going to have x minus 2y, x plus 2y. Okay, give it a box. Of course, you're going to check by foiling. Make sure you always check by foiling. First, outer, inner, last. You do that on your own. Now, the second one, we can't do it because it's a 3. But let's change this, I don't know, let's change it to a 2. Now it's a perfect square, and we can actually factor it. So 7x minus 4, 7x plus 4. Done. Okay, I'm going to change this to a minus because we can't do it as a sum of squares. Now it is factorable, but I'm going to give you a hint. Even though these are perfect squares, take a look. There's a GCF here and a GCF here. What is that GCF? Pull it out to the front and then do your factoring. And for that matter, there's a GCF here and a GCF here in number 4. Pull that GCF out to the front and then do your a minus b, a plus b. I will come back to you after I finish number 4. Okay, good luck. Okay, I brought my GCF to the front, and then I had this nice little guy to factor in the middle. Brought my GCF to the front, and then perfect square, and you a minus b, a plus b it. Notice number 4 looks like it can't even be factored, but once you take out that GCF, things start to come together. Now on these last two, they're a little bit interesting for their own reasons. Don't let the fractions get you down, and don't let higher orders get you down. So what we have here is the square root of x to the 4 is x squared, and then the square root of 9 is 3. But since it is in a denominator, keep the answer in the denominator. And then it's minus y cubed x squared over 3 plus y cubed. Remember, when we add exponents, y cubed times y, or when we multiply powers, we add the exponents. Okay, so that's a little rule there to keep in mind. All right, any even exponent is a perfect square. Okay, last but not least, this one's fun. Watch this. Maybe you gave it a try on your own already. X squared minus 4, x squared plus 4. If I was marking your test, I'd give you 1.5 out of 2. If you want to get the full 2 out of 2, you got to keep factoring. Look at that. We've got another difference of squares here. So watch this. X minus 2, x plus 2. Notice this is a sum of squares, so we just drop it. Drop it like it's hot. Okay, and then that gets the box. Okay, so good luck tonight. Remember, go back to the video, rewatch it if you're having any problems, and ask your questions tomorrow. Talk to you later. Bye. Happy mathing.